So we will start with this guest lecture on Six Sigma. First of all, let me give you a brief overview of Six Sigma. We have already discussed Six Sigma. At least we have done an overview. So more details about Six Sigma, about its terminology, where does its name come from. Dr. Hakeem, he will be discussing you. But you know about like this bell curve. We know that if we have any large population, they usually follow normal distribution. And in that bell curve, there are three standard deviation on right side and three standard deviation from the center on the left side. Six Sigma, that's a name. That's a reason why it's given this name Six Sigma. Six Sigma is a technique that is used for cost reduction. For the main purpose is to identify and cut cost and by reducing defects. So Six Sigma will be using highly sophisticated tools and techniques to eliminate defects from a process. And as a result of that, it will lead to cost reduction. And some other effects that are associated with this one is that Six Sigma is highly reputed. It's like a hot cake. Every organization, they usually ask their students to have at least some idea, because every organization, no matter you are working in a small retail store or you are working in Boeing or any big organization, every organization is concerned about cost. And in order to cut cost, you need some framework. The framework that would allow a systematic approach to cut cost and reduce defect. And Six Sigma is one of them. If Six Sigma is not there, we will be left with ad hoc tools and techniques, random tools and techniques, which may work, which may not work. But the advantage, the benefit of Six Sigma is that it provides a structured approach, a highly structured approach. Another fact, an interesting fact that's related to Six Sigma is that it has different types of levels. Like one of the highest level is called as black belt. It's the same type of terminology you are also familiar in martial arts. So like black belt. So those people who are expert in Six Sigma and those who have conducted some project and they have demonstrated their capability, knowledge and skill in Six Sigma, they are called as black belt. And Dr. Hakeem-Ur-Rehman, who is our guest lecturer today, he is also a black belt in Six Sigma. But beyond that, he is like an expert in the use of different types of tools and techniques, not just the science of Six Sigma, but also how you can use different types of software programs. And that makes Six Sigma is especially interesting. And I'm sure there are many more interesting things that are coming ahead. Without any further delay, I hand over to Dr. Hakeem.
Thank you so much, Dr. Asif. So it's really a great pleasure to present about the Six Sigma. So what I am going to talk about in today's lecture is we will try to define Six Sigma, like actually what basically the Six Sigma is. Then I am going to talk about the different types of the definitions of the Six Sigma, because some people says Six Sigma is the set of tools. Some people are talking about Six Sigma in terms of a philosophical perspective. When we are saying in a philosophical perspective, that means we are talking about with respect to y is equal to f of x, or we can say the IPO diagram perspective, which means input, process, and output perspective. So some people say Six Sigma is basically the set of matrices, or you can say metrics. And then we are saying that Six Sigma is basically a set of methodologies. So we will discuss in detail one by one what the meaning of set of tools, what the meaning of the philosophy, what the meaning of metrics, what the meaning of methodology. And then we will see there are multiple type of improvement methodologies which we can use to implement the Six Sigma. But out of that, most of the time we are applying the DMAIC methodology, which is one of the most famous methodology if we are going to implement the Six Sigma methodology. Then we are going to talk about the Six Sigma organizational structure. The organizational structures means whenever we are going to implement the Six Sigma, what kind of team structure we needed. Then I am going to talk about the two improvement programs, which is lean manufacturing, or you can say the lean production, and then the Six Sigma. So how they are differentiate with each other, and even now people are talking about we can combine them. They are called as Lean Six Sigma program. Then we will discuss certain Six Sigma frameworks, like we have the DMAIC, we have the DMADV methodology. Similarly, if you are going to implement design for Six Sigma programs, so what are those? So we are going to talk about that one. And then at the end, I will talk about the DMAIC, which are basically this methodology, and then we will try to compare it with the lean principles which we mostly use to implement the lean production, how they are related with each other. And then at the end we are going to discuss about certain common tools which we can apply in lean as well as a Six Sigma, and we will see that some set of tools we can only apply in the lean program, some set of program we can apply in the Six Sigma, but some of them are the common. So with the combination of all those tools, we can use them in order to implement the Lean Six Sigma program. So having said that, before going to talk about what is Six Sigma, so my question is, what is Sigma? So if we are saying, because these are the two words, so can anyone explain to me what is Sigma? Anyone?
So, Dr. Hakim, if I correctly understand, sigma, it means like standard deviation, and I think it's the Greek word, and that stands for standard deviation. I think we also use like these type of similar terminologies whenever we are dealing with a population and when we are dealing with a sample, and then we use these terminologies.
Exactly. So basically, sigma is the standard deviation. So as I mentioned, but this sigma is meaning the standard deviation, that is the narrow sense, which is basically the statistical measure to quantify the variation. So normally, instead of standard deviation, people are also using the variance. So now my question is, why not six variance? Why six standard deviation, or we can say why sigma? Okay, now this important question is because when we are talking about the standard deviation perspective, we are quantifying the variation in the process with respect to the actual measurement unit. When we are saying actual measurement unit, suppose the measurement unit is kgs, so we are going to get the answer variation in the kgs. If the measurement unit is millimeter, so we are going to get the answer in millimeter. But if we are going to use the variance, so the answer is going to be in a square. So that's why we will use standard deviation instead of variance, first of all, in terms of quantifying the variation with respect to the statistical perspective. But when we are saying with respect to the sigma in a broader sense or a business perspective, that means lesser the variation or the lesser the standard deviation, better the product is or the better the services is. So we would be able to deliver the product or the services faster and in a low cost. As Dr. Asif explained us, that Six Sigma is all about the defect reduction technique. So that means we are going to deliver the product fasterly as well as with a lower cost perspective. Because variation is the enemy of the customer satisfaction. Okay, customer will bear the average value. Okay, like if we are saying we are going to deliver a product in 25 minutes. Okay, if the on average value we can say that we will deliver the value in 30 minutes, that may not bother the customer. But if we are saying we will deliver the product in 25 minutes, but sometimes we are delivering the product in 40 minutes, sometimes we are delivering the product in 50 minutes, sometimes we are delivering in 60 minutes. So this variation is going to bother the customer. So in Six Sigma, the ultimate thing is we are going to reduce that particular variation. So talking about the Six Sigma perspective, first of all, I am showing you this particular bell diagram. That is basically the statistical perspective, or you can say the short-term perspective. So this bell curve is also known as a normal distribution, which you may have studied in your statistics class. So in statistics, when we are talking about this normal curve or a bell curve, so here what we are going to assume is that your population mean is exactly equal to the target value. What does that mean is, so customer have given us a certain target. Suppose we are producing a certain type of pen, and the diameter of that pen is basically the T. Okay, so that is our target value. And now they have given us this target value against a single product. Suppose they have said that you have to produce 1 million of this pen. So that is the order from the customer, but every pen's diameter should be equal to this T. But when we are going to produce that particular product, we cannot quantify the diameter of every pen. So we have to take certain samples. Okay, either we are going to take the sample of every 30 minutes or every 50 minutes, 5 pens, or you can say 10 pens or 50 pens, whatever the sample you are taking. So you will take the average of those sample, and then you will quantify whether that average is equal to the target point or not. Okay, but in statistics what we are saying that, so your average is always hitting the target. So that means if the diameter is 3 mm, so that means we will say that the sample mean, or you can say your population mean, basically the process is exactly equal to the 3 mm. Then after that, according to the statistical definition, which is known as the empirical theory, or you can say empirical definition, what is that? If your process having one up to 1 sigma level variation, then your process contain 68.27% good units. The remaining is going to be defective units. Okay, if your process contain up to 2 sigma level variation, then your process will be able to produce 95.45%, and so on. If we are going to talk about the 6 sigma perspective, that means your process would be able to produce 99.99, so which means almost zero defects, but out of 1 million. Okay, so this is ppm, stands for parts per million. Now the question is where this one comes from, where this two comes from, up to six. So if I'm going to talk about the statistical perspective, that if you remember in your statistics course, you are going to calculate the z-score. And what's the formula of the z-score is, that is x minus mu over sigma. Okay. So if we are going to interpret this z-score, that is the number of standard deviation your particular data point lying away from your mean value. So if I'm going to cross multiply that one, which means x is going to be mu plus minus z sigma. Why I am writing down plus minus? Because the normal distribution is a symmetrical curve. Whatever the area lying on the right hand side, the same area is going to be lie on the left hand side. So that's why we are writing down plus minus. Now if you see this equation, we can see that as we were defining the z, so x is basically indicating a particular point. Okay, this particular point, or could be this particular point, and we can say that this particular point is lying how much number of standard deviation lying away from the mean value. So which mean this z is your z score, that is basically indicating the sigma level. So generically people are using, instead of using z sigma, so they are calling it as k sigma. So as we were talking about, Six Sigma is basically the two words. One is indicating sigma level. So this is sigma level. Okay. whereas the sigma only is basically the standard deviation. So now the question is, how can I improve my sigma level? So whenever we are saying the sigma level, that is also mean the performance level. So higher the sigma level is indicating the higher the performance level is. Okay, so we can improve our sigma level by reducing the sigma value, or you can say by reducing the standard deviation value. Okay, but if you can see this particular diagram, this is purely a statistical perspective when we are saying that our population mean exactly equal to the target point. And we have, if we have one sigma level, if we have two sigma level, how much conforming unit we are producing. But if we having the six sigma, we are producing almost 100% conforming unit, which we, out of 1 million we are producing almost zero defect unit. Okay, but because the six sigma concept is comes from the Motorola company, and they said that in a longer term it is impossible to hit the target value. So your process mean is going to be shift, either it is going to be shift on the left hand side, or either it is going to be shift on the left hand side. So they have given us a question which is known as 1.5 shift theory. Okay, so but remember that there is no theoretical justification why 1.5. It could be one sigma shift, or it could be two sigma shift, or a five sigma. But they have tested it. They have given this value as an empirical result. So they studied more than 100 companies' processes, and they have given us a certain question that your process mean might shift from your target point up to 1.5 sigma. Either it could be the right hand side, or either it could be the left hand side, but your process must have smaller variation. It should be live within the specification limit. Okay, as I have given you the example earlier, that we are going to, if we are going to produce a ballpoint and it having a specification limit 3 mm, that is the target point, plus minus zero point 0.5. So which means if the ballpoint diameter is going to be between 2.5 to 3.5, we are going to accept it. If it is going to cross the specification, we are going to reject it. So that means, according to the Motorola company, if your process having the lesser variation, although your process mean is shifted up to 1.5, but your process variation must be as small as possible, that it should be live within the specification limit. So remember that whenever we are talking about the specification limit, it is always based on the individual product. But when we are looking at our process and we are calculating the limits, which are known as natural tolerance limits, okay, which are basically calculated based on the mean of our process plus minus k is the level of your sigma and the standard deviation. Okay, so natural tolerance limits are always calculated based on this equation, as we can see from here. Okay, so these this is basically our target point, or you can say the mean value to up to that k level. So what this 1.5 shift sigma theory is, it is saying that if your process mean is shifted up to 1.5 either right or either left, okay, so, and your process is working at one sigma level, how much percentage of good unit you would be able to produce, and out of 1 million, okay, how many parts you are producing defective. Okay, similarly, if we are working on 2 sigma level, out of 1 million, how many defects we are producing. And if we are working on 6 sigma level, then out of 1 million, we are producing basically 3.4 defects per million. Remember that this 1.3.6, basically this is the Motorola company's standard. So they are saying that if your company is working at six sigma level, so which means they are saying that out of 1 million your process is producing only 3.4 defects. Okay, so remember that here there is a mistake. This is not the defective, this is basically the defect. So there is a clear cut difference between defect or the defective. So what is that? So that whenever we are talking about the defective, that means the whole product is okay or whole product is not okay. Okay, so that means in a one defective product we may have one defect, or we may have more than one defect. Okay, so that whenever we are talking about with respect to the defect perspective, we are talking about in a rate perspective. That means the number of defects per unit. Okay, whereas whenever we are talking about the defective perspective, that means we are talking about only yes and no perspective. Okay, so once again, people are mostly confusing about uh, how in a one way we are saying that smaller the sigma is, that means higher the performance level is. So when this value is going to be start increasing, automatically our bell curve is start expanding. So that's why people are mostly confusing about this concept. So how you can clear your concept about that? So take always in a comparison perspective. So let me give you the example. Suppose we have the two processes. Okay, once we have the process mean is 10, okay, and the standard deviation is 2, and we said that we have improved our process mean is still 10, but the variation is start decrease, and we have taken some corrective measures, and the standard deviation is now 1. Now, if I'm going to calculate my limits, okay, as we have seen that from the empirical definition, that mean plus minus 1 sigma. So if I'm going to calculate this, the values of this limit, this is going to be 10 plus minus 2, so which mean 8 to 12. Similarly, if I'm going to calculate mean plus minus 2 sigma, so this is going to be 10 plus minus 4, so this is going to be 6 to 14. And if I'm going to calculate mean plus minus 3 sigma, this is going to be 4 and 16, right? uh, but similarly, if I'm going to calculate with the help of this one, this is going to be 9 and 11. So this is going to be 8 and 12 with respect to 2 sigma perspective. So over here, this is going to be 7 and 13. But if you see this one and this one, when our standard deviation is higher compared to this one, so our process is working on one sigma level, we are getting the same limit value. When our standard deviation is start decreased, okay, that means the variation is start decreasing, we are getting the same values, or you can say same limit, but with the higher sigma level. So that's why we are saying, if you would be able to reduce the value of the standard deviation, your performance level or your sigma level start increasing. Okay, so this is very important concept. Okay, I hope it's clear about the standard deviation perspective, as well as their performance or the Six Sigma level perspective. So if you have any question till now, so most welcome. Any question?
Uh, Dr. Hakim, just a question. One
Yeah.
student asked, uh, is recording going on?
Yes. Yes.
I mean, yeah, okay, thank you.
Yeah. Okay, now we are going to define with respect to Motorola company's perspective, as well as with respect to American Society of Quality perspective. So if you read the definition of from both Motorola or ASQ, what we are getting is that Six Sigma is basically a data-driven methodology. It's a scientific methodology which is used to produce, or you can say which is going to be improve our processes. Okay, so that means it is going to be used for the process improvement or the product improvement perspective. Okay, and it is a breakthrough improvement strategy, so which means whenever we are going to implement the Six Sigma, we would be able to get a significant improvement in terms of financially, in terms of the customer satisfaction perspective. So similar kind of definition you can see from the American Society of Quality. So they are saying it's a business methodology to improve the capability of the business processes, to increase the performance and decrease the process variation. Okay, so by reducing the defect reduction, and ultimately we are getting the profit, higher profit, employer satisfaction level, as well as improvement of the quality product. So I hope it's clear what is basically the Six Sigma is. Now we are going to see the Six Sigma with respect to different opinion perspective. Like if I am saying Six Sigma is basically a measure. So what does that mean? So as we have seen from the previous slide, that Six Sigma, whenever saying in terms of measurement perspective, we are talking about in terms of short-term perspective as well as the long-term perspective. So in a short-term perspective, as we have seen over here, so this is the short-term sigma level measures. So this is the long-term perspective. So as we have discussed that short-term means we are assuming that our process mean is hitting the target, whereas in a long-term perspective, we are assuming that our process mean is shifted up to 1.5 sigma level. Even either it could be the left hand side or either it could be the right hand side. So remember that whenever we are reporting the sigma level, so we have to add this 1.5 shift, because people will assume that you have added that shift because Six Sigma is come from the quality management field, and quality management is always talking about the long term perspective improvement, not the short term perspective. Okay, next thing is that Six Sigma is basically a set of qualitative as well as the quantitative techniques. What are those tools or what are those techniques? We will talk about in a minute. And then people are talking about Six Sigma is a methodology. Okay, so when we are saying Six Sigma is a methodology, most of the time whenever we are going to implement the Six Sigma, either we are using a DMAIC methodology or either we are using a DMADV methodology. So what are these methodology? We will discuss in detail. So basically D is mean define, measure, analyze, improve, control. So this is define, measure, analyze, design and verify. So the major you can say difference between these two methodologies are, so DMAIC methodology is always implemented when we want to improve our existing process. Okay, whereas DMADV methodology is implementing when we are designing a new process or we are re-engineering a process. So over there we have to adopt the DMADV methodology. Okay, so what are these methodology? We will discuss in detail in after few slides. Okay, then Six Sigma is a philosophy. So what does this mean? So we have whenever we are saying the Six Sigma is basically the set of causes, that X is basically the input or you can say the causes, and Y is basically your critical to quality. So that means whenever saying Six Sigma is a philosophical perspective, that is basically the set of inputs, and we have a one critical to quality. Okay, that is our basically response variable. Like as I am giving the example from the pen perspective, that the critical to quality is the diameter of a pen. Okay, so now we want to see that what are the causes behind this, that we are not able to meet the diameter as per the specification perspective, whether it is due to the man's factor, could be his we didn't train him enough. Okay, could be he's not qualified enough in order to produce that particular product. Okay, could be another causes. Similarly, the cause could be related to the machine. Okay, maybe the speed is too high. Okay, maybe the tools are not properly fit. Similarly, we may have with respect to the mother nature, or you can say environmental perspective. So could be multiple factors are basically those are the causes behind it, that we wouldn't be able to meet the specification limit. So our ultimate target is we have to identify those causes, and against those causes we have to take some corrective or preventive measures. However, we would be able to meet that critical to quality as per the specification limit. So among these definition, I really like this one because this is the most important definition. Usually whenever we are starting the Six Sigma project, the starting point is always should be the IPO diagram, which means y is equal to f of x. This is also known as IPO diagram. So whatever the process you want to improve it, so identify the critical to quality which you want to meet according to the specification limit, and what are the causes behind that particular process which we wouldn't be able to meet the specification if we are not. Okay, and what are the causes behind it that are basically causing the lot of variation against that critical to quality. And lastly, people are saying that Six Sigma is basically the set of metrics. So, which means in order to quantify the Six Sigma, we can quantify multiple type of metrics in order to know whether our process is working on one Sigma level, three Sigma level, or a Six Sigma level. Okay, so we will also discuss in detail. Now, what I am going to do is I'm going to discuss these different types of opinions one by one. So let me first discuss Six Sigma is basically the set of tools. So as we have discussed earlier, whenever we are saying Six Sigma is a set of tools, so it contains some qualitative and quantitative tools. So basically, Six Sigma having the three set of tools. Some are related to the quality management, some are related to purely the statistical perspective, some are related to the management perspective. Because when we are dealing with the Six Sigma project, we should have certain knowledge related to the project management, organization behavior, human resource management. We should have statistical knowledge in terms of different tools such as control charts, capability analysis, okay, and so on. Similarly, related to the quality function deployment, failure mode effect analysis, statistical process control, and so on. So remember that in Six Sigma, we have hundreds of tools and techniques, but every tool is going to be junk if we do not know which tool should be used for what purpose. Like normally the quality function deployment tool is used to translate the customer requirement into the final product or the final process perspective, what's according to the customer needs perspective. So you can say that so quality function deployment is basically used to know what customer want from us from this particular product. Similarly, FMEA is basically normally used to prioritize the risks or prioritize the factor which are the most important in terms of the risk minimization perspective. Statistical process control charts are basically used to monitor the process. However, we should be able to control the process if there is any, you can say, variations in the process or it is good. Moving out of the control limits and so on. So these are the hundreds of tools and techniques, but we have to pick up the right tool at the right you can say time perspective, depending upon what are the question we are going to answer it. Okay, now I'm going to talk about Six Sigma as a philosophy perspective, which is basically the y is equal to f of x, that is also the IPO diagram. So as I told you, IPO stands for input process output diagram. Okay, so that is we are visualizing our process in terms of input as well as output relationship point of view. So whenever we are saying input, that means we are trying to identifying all those factors which are affecting a response variable. So normally when we are delivering a service, when we are delivering a product or we are performing certain tasks, okay, so in order to perform that particular service or a product or a task, we have set of inputs or you can say set of factors we are using to convert the inputs into the output. But remember that whenever we are talking about the Six Sigma perspective, this IPO diagram is so what we are interested in, whenever we are delivering a service, there are certain components or you can say attribute attached to that output. Like if I am saying I am delivering a pizza. Okay, so delivering a pizza, there is a certain attribute that is attached, which is mean how long customer have to wait in order to get the pizza. Okay, so that is the attribute attached to that particular product is. Similarly, if I am saying that we are producing a product, so like what is the diameter of the product, what is the weight of that product, okay, what is the cycle time in order to produce the product, what is the lead time in order to produce that product. So certain attributes that are attached to that particular output is. Similarly, if we are saying we are performing certain tasks, how long would it take to complete that task? Okay, whether we are performing tasks correctly right at the first time or not. So these are the attributes that are attached to the output, and those attributes are known as outcome. So remember that your critical to quality or your critical to customer is always should be the measurable outcome. Okay. So that is also known as the critical to quality, as I am showing you over here is. So whenever we are taking the output, we have to basically consider the attribute attached to that output, which is known as the critical to quality or our outcome. So let me give you certain examples. Like if we are, I'm working in a production department, and the output could be the number of items we are producing, the type of products we are producing, and against that we have certain outcomes. Okay, could be the percentage of defective we are measuring is, we are measuring the cost of production per item, we are measuring the number of items. So these are basically the attribute attached to that one. Okay, so I believe you got the idea what is the difference between the output and the outcome. The outcome could be a negative, outcome could be a positive. So how we can define the outcome? That is basically the attribute that are attached to the output. Okay. So similarly, if I'm giving the example of the university, so the output could be the number of students, the number of teachers the university have, the number of programs. Okay, but outcome is going to be the graduate competency rate, job placement rate, and so on. So which we want to measure it in order to improve the performance of that particular organization or a particular process. Similarly, if I'm giving the some testing department perspective, if I'm giving the post office office perspective example, and similarly human resource development perspective. Okay, so for every particular process, whenever we are taking the output, so you have to identify the critical to quality, which means the measurable outcome, because the quality objectives are always developed based on the outcome perspective. So that means if I am saying that I am working in a production department and my critical to quality I am considering right now is the percentage of defective units. So suppose if we are saying that I want to reduce this percentage of defective unit from our production department. So what are, so this is basically our output. Now we will see what are the possible input factors are which are basically causing to increase this percentage of defective, whether it is due to our labor, whether it is due to our machine or certain policy. So what are the basically input factors are? Okay, so in order to identify those inputs, okay, like let me show you some more examples with respect to the IPO diagram perspective. Like I am giving the from the HR training process perspective example, from the manufacturing injection molding parts perspective, so here from the finance accounts receivable process perspective. So like if we are talking about with respect to the finance perspective, the process is accounts receivable. So the output could be, so that is basically the output means that is basically the outcome perspective. Okay, that is the percentage of late payment. Okay, invoice defect rate, cost to produce per invoice. So what are the causes behind that one? That is depending upon what type of invoice we are preparing is. Okay, and so on, depending upon the customer client relationship could be the factor that is creating certain output problem is. So remember that whenever we are starting the Six Sigma project, the first thing we should know is, first of all, we need to identify the critical to quality which we want to improve, whether we want to reduce the percentage of late payment, whether we want to reduce the defect rate in the invoices. And then once we have identified this one, then we are going to identify what are the possible input factors or the causes which are basically affecting this one. Okay, so you may have studied the cause and effect diagram, or you can say fishbone diagram. So this diagram can be used to identify these causes. Similarly, as I'm talking about that, like we have to pick one of the critical to quality or one of the critical to the outcome. Okay, so like out of these four or five critical to output, so how you can pick that one using the Pareto chart, okay, or a Pareto diagram to prioritize which are basically creating the most of the problem, whether the percentage of late payment are the most critical one because it is creating most of the problems, or whether it is due to the defect rate in the invoices. So we can prioritize the critical to quality with respect to the frequency, okay, or even with respect to the cost perspective, and then after that we can identify the possible causes. But at the initial stage we can develop the IPO diagram in order to know the possible causes. So I hope you got the idea regarding the philosophy perspective. So even we can extend this philosophy even from IPO diagram to SIPOC diagram, okay. So that means where this input comes from, that is from the supplier. Okay. And we can identify which type of input comes from which supplier. So when I am saying supplier, I am not talking about the external supplier only. I am also talking about the previous department could be acting as your supplier. Okay, and where this output goes, that is goes to the customer. Okay, not only the external customer, it could be the internal customer. That means the next department acting as a internal customer. Okay, so I hope you got the idea regarding the philosophical perspective. So till now we have seen three perspective. One is Six Sigma as a measure. We talk about the short term perspective as well as the long term perspective. We talk about Six Sigma as a set of tools perspective, that is basically the set of quality, statistical and management tools. And lastly we talk about Six Sigma philosophy. Now I'm going to talk about the Six Sigma matrix perspective. Okay, so matrix mean we want to quantify the performance of our process. So how we can quantify the performance of process performance? That is with the help of set of metrics available we have. So that is basically defect per unit. We have parts per million, okay, or we have defect per parts per million, yield, and there are different type of yield, first pass yield, and we have roll throughput yield and the sigma level. So ultimately, we are interested in order to identify the sigma level of our process, which is basically indicating our performance level. As we have discussed earlier, that higher the sigma level is indicating the higher the performance level. And how we can improve the, or you can say increase the sigma level, by reducing the standard deviation or by reducing the variation. When we are saying by reducing the variation in the process, that means by reducing the defects per unit, or you can say by reducing the defects per million opportunity. Okay, so now I'm showing you some examples in order to quantify the sigma level of our process, or you can say performance level of our process. So here I'm giving the example. Let's say we are producing this pair of shoes, and we have collected the data from our production floor, and we have taken the 100 pairs as a sample, and out of 100 pairs we found that we have seen 10 defects. So remember that when I am saying 10 defect, that doesn't mean 10 pairs were defective. This 10 defect could be only on a one pair out of this 100, or could be on different 10 pairs. Okay, so remember that as I told you earlier, defect and the defective difference is, defective mean the whole thing is bad or whole thing is okay, whereas defects mean the number of defects per product or the number of defects per pair perspective. So the first metric we are quantifying based on this one is, that is defect per unit, and the formula is the total number of defects divided by total number of units, which is that mean 10% defect, okay, or we can say zero point 0.1 defect per 100 pair. Okay, the next opportunity metric we are calculating is, that is DPO, which is defect per opportunity. So what the meaning of the opportunity is, Opportunity is the number of way you are checking the product in order to find out the defect, or you can say that is the number of component on a product. But the better definition of opportunity is the number of way you have created to find out the defect. Okay, the number of way you have created to find out the defect is basically the checklist, or you can say the inspection points. Whether you will say, how you will say, so this product has a defect, whether there is a mark on this particular product, we will say there is a defect, whether the color changing is the defect. So we have to list down the number of components which we are going to check on this particular product. That is going to be the opportunity. So what I am considering over here is that I will check every part from this particular pair in order to say this is the opportunity. So one part is going to be known as the opportunity. So because in a one pair, so we have two parts, so that's why I'm considering as a two opportunity. But opportunity is actually right now I'm considering as a product perspective, but you can also creating the inspection points could be your opportunity. So, but over here, if I'm considering the two opportunities, so how can I calculate DPO? That is, the formula is going to be number of defects divided by number of units multiplied by the number of defects opportunity per unit. So which is going to be 10 divided by 100 multiplied by 2. Or simply we can say that DPU divided by the number of opportunity, which is 0.05. Now we are interested to find out another metric, which is DPMO, which is defect per million opportunity. So simply we are going to multiply the DPO answer with 1 million. We are going to get the answer of DPMO. Okay, the next thing, if I am interested to find out the percentage of good unit, which is basically our yield. So the answer is going to be 1 minus DPO, that is 1 minus, right now in this particular case is 0.05, which is 95%. So based on this yield or based on this DPMO, we can calculate our sigma level or the process performance level. So if I am using the DPMO value in order to know the sigma level, so we have a table, that is this basically conversion table. So if you write down on a Google, like I want to find out the sigma level from the DPMO value, you will see this particular table. As we have seen from this, the DPO answer is 50,000. Okay, so if we see from our defect per million table perspective, so 50,000 is going to be lie within this particular range. So what is the sigma level? That is going to be like between 3.1 to 3.2. Okay, but we cannot quantify the sigma level accurately with the help of this conversion table. So approximately we are saying that that is going to be like between 3.1 to 3.2. But if I'm going to interested in to find out the exact sigma level, so I can use Microsoft Excel's formula, that is basically this one, which means norms inverse, that is the inverse normal distribution. Then we have write down the value of the yield, okay, which is 0.95, okay, plus 1.5, that is basically the shift of 1.5 sigma. So how we can do that? I have already prepared an Excel sheet, which I believe Dr. Asif shared with you. So the input data we needed, that is the number of defects. Okay. So right now, if I'm considering this particular example, the number of defects are 10. So this is 10. The number of units were 100. Okay, the number of opportunities was 2. So the rest of thing, we have applied this particular formula in order to quantify the sigma level. So as we can see that this sigma level is a short term sigma level. Over here I have applied equal norm inverse and the value of yield, which is 0.95. Okay, but whenever we are going to report the sigma level, we have to add 1.5 shift theory. So that's why we have added 1.5. So actually this organization is working on 3.1449 sigma level. Okay, and the similar answer we were getting in the DPMO answer. So which means this conversion table, they have already added that 1.5 shift. So I hope you got the idea how you can calculate the sigma level from the process. So remember that right now, whatever I'm giving the example, that is based on the discrete data. So for the continuous type of data, so the sigma level is going to be calculated based on the normal distribution. The method is different, which we are not going to discuss in today's lecture. So I'm giving the example from the discrete data, like if we have the information with respect to the number of defects perspective. Okay, over here I'm giving the example from the telecom sector. So if you go through this example and let me know the total number of defects in this particular process and total number of unit in this particular process, what are the number of opportunity, however we would be able to quantify the sigma level. Can anyone tell me if I'm giving the 1 minute?
Dr. Hakim, can you please repeat the question?
The question is, can anyone explain to me the number of defects in this particular example we have? Like, I want to calculate the sigma level as well as DPMO from the telecom network, and this telecom network is down for 500 minutes in the year of 2005. So based on this statement, what is our critical to quality? That is certainly the downtime. Okay, so the question is, I want to quantify the sigma level as DPMO. So that means what are the number of defects we have? Okay, what are the number of opportunities we have in this particular example, and what are the total number of units we have? Because if we know these three things, we would be able to quantify the sigma matrix. Can anyone tell me? Okay, okay, so
So I guess this 500 minute, that's like one of the most important thing that will determine customer satisfaction or whether they will continue with that service or not.
exactly. So right now, basically, from this telecom sector, we are saying we have collected the data for the year 2005, and we have seen that in this entire year, this company has the downtime for 500 minutes. So first of all, they are considering the measurement unit as a minute. So they will say if our network is down for even 59 seconds, we will not say this is a downtime. Whenever there is a at least 1 minute or a 60 second, we will say that is considering as a downtime. Okay, so obviously the specification limit is that we want there should be no downtime. We are measuring in a minutes perspective. Okay, and the critical to quality is we want to reduce this downtime is. Now the number of defects are going to be 500 because in a year 2005, so this network is down for 500 minutes. So that means the number of defects are 500 minutes. Now we are interested to find out the number of total units. So in a year, how many minutes we have? So we know there is a 365 days in a year, and in a day, how many hours, and in 1 hour, how many minutes. So by multiplying this one, we would be able to get the total number of minutes. So that is basically the total number of units. Okay. So now, in order to identify the opportunity, whether we are saying that we are going to consider the seconds as a measurement unit to find out whether the network is down, or whether we are considering the minute. So as I'm telling you that even if the network is down for 59 seconds, so they are saying that we will not consider as a downtime. When there is exactly a minute, 60 second or more, then we are going to consider that the network is down. So that means we are measuring in terms of minutes. So that's where the opportunity is going to be one. So if you are considering in terms of even seconds, so based on this data, the opportunity is going to be 60, because even the network is down for 1 second, your opportunity is going to be you are going to be find out the defect. Okay, so that's why whenever we are deciding the number of opportunity, so that is the most critical task. So you have to consider it very carefully. So whether you are picking the opportunity, like in this particular example, is going to be seconds or a minutes or whatever the unit you want to say is. So based on this data, that is number of defects were 500, the total number of units were this one, the opportunity is one. So we are calculating the rest of the thing. And even you can put into the Excel sheet, you would be able to get the answer of all these things. Okay. Now, uh, in this particular example, can anyone tell me like the same number of defects, okay, and number of opportunities we have, and the total number of units? So what are the total number of defects we have? So we want to quantify the sigma level. Anyone? It's,
Is it the test, the 3,432 that are
ye-
rejected?
yes. So number of defects we have 3,432 were defects. What are the number of opportunities?
83. Oh,
So
no.
they are basically performing 8 individual check to test the quality of the drive. Okay, so that means 8 are the opportunities. Okay, so basically they have identified 8 different points on a hard disk. So once those 8 checks were okay, then they will say that the product is fine. So that means the opportunity point to find out the defect are 8, and the total number of units they are producing, which is basically 83,934. Now, based on this information, we would be able to get the sigma level. Okay, that is right now this organization is working on 4.07 sigma level. Again, we can use that Excel sheet. Okay. Okay. Now, from this particular example, anyone, the same number of defects, a number of units, and the number of opportunities for our billing process.
Defects.
Yeah, we have 60 defects. The total number of units we have, that is 250 bills. And what are the opportunities?
1.
One. Very good. Because we are only checking whether the bill is correct or not. Okay, so the opportunity is one. So based on this, we can calculate the sigma level. What about the this one? For this particular process, which is basically the delivery ordering process, number of defects are equal to
41, well, 17.
41 plus 17, yes, which is going to be 58. Total number of unit is going to be 500, and how many opportunities we have?
1, 2.
Two. So we are checking whether it is going to be delivered late or incorrect order. So we have two opportunities. Okay. So based on this, we can calculate the sigma level. Okay. So what about this one? This is from the banking sector perspective.
50 defects.
Yeah, 50 defects, and opportunities we have
14.
14, and total number of units we have 300, right? So based on this, we can calculate the sigma level. So similarly, I am giving the next example. So we can find out that the total number of defects were 300. The total number of units we are producing is 4,500, and the critical field which we are inspecting is 12. So the opportunities are 12. So based on this information, we can calculate the sigma level. Okay. So now we are going to talk about the methodology perspective. So as we were discussing earlier, so we have normally the two methodology which we can use to implement the Six Sigma, depending upon what are the target we have, whether we want to improve our existing process or whether we want to re-engineering our process. So when we are saying existing process, So for that, we have two programs. Either we can purely implement the Six Sigma, or either we can implement the Lean Six Sigma. So what this Lean mean is, so we will discuss later. But right now, remember that because we are talking about in terms of methodology perspective. So if you want to improve your existing process, we can implement the DMAIC methodology. But if we want to re-engineering it, okay, then we can apply the DMADV methodology. The only difference lie at the last two phases, okay, which is basically design and verify. Over here, it is improve and control. Okay, so that means in every particular phase of the DMAIC and DMADV, we are basically trying to answer a question. So what type of question we are going to answer is, we will discuss in a minute what are those. But before that, let me tell you, there are multiple type of methodologies we have. Even you can implement the Six Sigma using the PDCA cycle, okay, which is basically plan, do, check, act. You can use DMAIC methodology, you can use A3 reporting, you can use AD problem solving process in order to implement the Six Sigma. But most of the time, as I told you earlier, that whenever we are talking about Six Sigma, people mostly prefer to improve the existing process by implementing the DMAIC methodology. But when we are talking about the Lean methodology, so what is Lean? So we'll talk about later, but mostly people are preferring the A3 reporting. Okay, but all four or five methodologies are same. Basically, we are doing the same thing in these methodology. It doesn't matter whether you are adopting the PDCA cycle or whether you are adopting DMAIC or A3, whatever. Okay, but right now, as most of the people are following the DMAIC whenever there is a Six Sigma project, or whenever there is a Lean Six Sigma project. So let's see what this DMAIC methodology is. So as we were discussing, DMAIC stands for define, measure, analyze, improve, and control. So in a define phase, we are trying to answer certain questions. So that means whenever we are picking a project for the Six Sigma implementation, so in a define phase, we are trying to answer what is importance of this particular project to our business in terms of financially, in terms of the customer satisfaction perspective, and how would it take to complete this particular project is. So that means we are trying to answer in a defined phase with respect to the customer satisfaction perspective, with respect to the benefit in terms of financially, as well as how long would it take to complete the particular project. So we have set of uh, quality and management tools and techniques. Using those tools and techniques, we are trying to answer this particular question in a defined phase, such as we are in a defined phase, we are developing a project charter in which we try to answer what are the problem we are going to solve in this particular project, and how much improvement we have set as a target, how long would it take using the Gantt chart from the project management or CPM method from the project management, in order to answer how long it will take to complete the particular project. We are using some financial management measures such as net present value, or a payback period in order to know how much benefit we are getting after completing this particular project. So basically, in a defined phase, we are trying to answer what are the benefit we are getting after implementing this particular project in terms of customer satisfaction perspective, in terms of the financial perspective. So once we have done this one, the next phase is the measure phase. So in a measure phase, we are trying to answer is how well we are doing right now, or you can say how we are currently performing. So that means we are giving the answer of the current performance level of your particular process. How we can do that by calculating the sigma level of particular process of ours. Okay, so that means where we are standing right now. So once we know where we are standing right now, now we can improve. Now we can set the target, uh, how much improvement we want from now. Like right now, if I am working on 2 sigma level, I want to improve it in the next 6 months I want to reach up to 4 sigma level or a 4.5 sigma level, and so on. So once we have identified where we are standing right now, the next thing is we are going to answer it. What is wrong with the current process that we didn't able to get our desired state or the desired sigma level? So which means we are trying to identify the all possible root causes behind that particular problem. So let me get back to you the same example which we were discussing earlier, that is that we are producing a ballpoint and having the critical to quality is that is basically the diameter. Okay, and the customer says that the diameter should be lie between 3 mm to you can say zero point 0.5. Okay, and we are not able to reach this specification limit, or there is lot of variation. So now we are trying to find out all set of causes behind this particular problem is. Okay, so we are trying to identify all the causes. So maybe you would be able to identify 40 or 50 causes. So in an analyze phase, what we are doing is so we are trying to sort it out what are the critical causes out of these 40 or 50 are which are basically actually affecting your critical to quality is. So in an improve phase, once out of these 40s we have identified the critical causes, maybe could be 4 or 5 are the more critical one. Okay, then in an improve phase we are trying to identify the optimum setting of those causes. Optimum setting of those causes mean is like, for example, if I am saying that one of the cause is machine and one of the factor of the machine is speed, due to the speed we are not able to produce that particular diameter. So which mean, should we set the machine setting at a low level or at a medium level, or we should set the high level? So we need to identify this optimum setting. So this optimum setting we are going to identify in an improve phase, such as we can use design of experiment is one of the very good tool in order to know which would be the more appropriate setting would be. Could be you can apply FMEA in order to know the optimum setting of the machine. So depending upon the technique, we are going to identify the optimum setting of those root causes which should be able to produce the required quality product. And because we know that Six Sigma is basically a breakthrough improvement strategy, so once we have get the improvement, okay, or achieve the improvement, then we need to monitor it. However, our process should be stable. So whatever the we have done the improvement, it should be stable over the time. Okay, so this is the overall methodology of the DMAIC, which we use to implement the Six Sigma, or which we use to improve the current process. Now, the question is, in order to implement the Six Sigma, what kind of team structure we needed? So first of all, we have the steering committee or the quality council, which is basically normally as head of the department or the owner, which are basically initiating the Six Sigma project. And then we have a champion. The champion is the person who is basically the process owner. Whether we are going to implement this Six Sigma project on the cutting department in the textile sector, or whether we are going to implement in a swing department or a finishing department or a packaging department. So whatever the process we are going to improve, so the responsible person of for that particular process is going to be champion, because this person may do not have any technical knowledge about the Six Sigma point of view, but he has the complete knowledge about that particular process. However, if we need certain information about that process, so that guy is going to be help us. What are the possible critical to qualities are, what are the possible causes may have. And then we have the master black belt. So this master black belt is not compulsory the part of the team structure. He is basically acting as a trainer or a coach. So the main person who is heading the Six Sigma project is the person having the black belt. He is acting as a project manager. Okay, so in a Six Sigma project manager, we have a Six Sigma team, which may have the green belt persons, or even below the green belt we have the yellow belt guy as well. So these belts are nothing but the knowledge level of related to the Six Sigma. And obviously in a black belt level you will get the all the knowledge related to the Six Sigma or the Lean Six Sigma perspective, whereas the green belt is basically having the knowledge of Six Sigma, but they have covered the lesser you can say content from the Six Sigma tools and techniques. Okay, so normally the green belts are acting as a team members, whereas the black belt acting as a project manager, and master black belt acting as a coach or a trainer. Even if black belt are facing certain problems, okay, so he can contact to the master black belt. So master black belt is a person who having the black belt with having the experience of at least 4 or 5 black belt projects. Okay, so this is the structure we needed in order to implement the Six Sigma project. Now we are going to talk about what is the difference between the Lean and Six Sigma. So first of all, as we have discussed earlier, basically the Six Sigma concept, basically idea comes from the Motorola company, and they implemented this Six Sigma project in order to improve the quality of the process. Okay, whereas the Lean manufacturing concept comes from the Toyota production system from the Japan. Okay, the ultimate focus of these two programs are the same, so they want to deliver the value to the customer. Okay, but the theory behind it, Six Sigma is always talking about to reduce the process variation, whereas in Lean the ultimate target is to reduce the waste in our process. When we are saying waste, that means if I am talking again in terms of input, process and output perspective, so when we are converting the input into the output in a process, what we are doing some set of activities to convert this input into the output. And this set of activities is basically the combination of value added plus non-value added activities. So all those non-value added activities are known as waste, because how we can define non-value added activities, all those activities against which customer is not ready to pay us. So that means that is a non-value added activity. So Lean says try to remove those non-value added activities. However, the flow of the input is going to be improved. Okay, whereas Six Sigma, we are ultimately focusing on the problem focused. Okay, but the ultimate target of both the programs are to deliver the value to the customer. That is the main element is. Okay, so normally, if we are considering these two programs separately, normally Lean is saying that it's a low-hanging fruit program, whereas Six Sigma is a high-hanging fruit program. So what does this mean is, so if you want to improve day-to-day process, or you can say in a small step process, you want to improve it, go for the Lean. And for Lean, so there is most of the thing we needed is the common sense, because most of the tool in the Lean are the common sense based tools, whereas in Six Sigma we this is basically the heavily data driven methodology. So for that we should have the knowledge of heavily statistical based techniques. So that's why whenever we will get the improvement through the Six Sigma is going to be huge, whereas in Lean we are going to improve our process step by step, and we are continually pursuing the process. So it's up to you whether you want to adopt the Lean philosophy or the Six Sigma philosophy. Okay, okay, and now as we were discussing earlier, that there are two type methodology. One is a DMAIC methodology, another is a DMADV methodology. So if you want to improve your existing process, either we can adopt the Six Sigma program, or either we can adopt the Lean Six Sigma program. The ultimate focus of the Six Sigma is going to be variation reduction, whereas the ultimate focus of the Lean Six Sigma is going to be waste reduction, or even waste plus variation reduction. You can say that with the combination of Lean Six Sigma. But if you want to build such a process which should be reliable, which should be robust, then we are going to adopt the program of DFSS, which is designed for Six Sigma program. For that, we are going to implement DMADV methodology. And here I am giving the some examples which we can adopt in the DMAIC cycle. Like if this is a pure Six Sigma program, we can use this set of tools. If it is a Lean Six Sigma program, here I am listing down most of the lean related tools. Okay, you can also add some Six Sigma tools. Similarly, over here we have some set of tools which we can adopt in order to implement this methodology. So depending upon your objective, whether you want to improve your existing process, so go for either Six Sigma project or the Lean Six Sigma project, or if you're re-engineering it and you want to build such a process which should be robust, which should be reliable, okay, and it's a very new process, then go for the design for Six Sigma project. Okay, basically in this particular slide, what I am trying to do is we have already discussed this DMAIC cycle. Okay, uh, in this particular slide, I am listing down basically the lean principles. So normally, whatever we are doing in the DMAIC cycle, we are trying to doing the same thing in the lean principle is. But the major difference between these two philosophy is, as I am telling you earlier, that in Six Sigma, in the improve phase, we are trying to get the breakthrough improvement, which means the significant improvement from one point to another point. Whereas in lean, we are doing day-to-day improvement. So that's why in lean, instead of monitoring the process to check the stability of the process, we continually pursue the perfection, which means we are trying to continually improve the process, whereas in Six Sigma we try to stable the improvement which we have already done. So let me quickly go through what these lean principles are. This is basically value stream, flow, pull, and perfection. So what we were doing in the define phase, we are trying to identify the importance of this particular project to our business in terms of financially, in terms of customer satisfaction perspective. So basically the same thing we are doing in specifying the value. So that means what customer want from us. So we should be able to know the exact requirement of the customer. So that is specifying the value. And in a value stream, what we are trying to do is we are trying to understand our process from start to finish, which means end to end, we are trying to know about our process, trying to identify what are the value added activities, what are the non value added activities. Okay, however, we would be able to remove those non value added activities to improve the process. The same thing we were doing in the analyze, measure as well as analyze phase. So in an improve phase, we are trying to identify the exact setting of the inputs. So the same thing over here we are doing in flow and pull perfection. So the flow is indicating whatever the object is moving from your process as an input. Like if I'm giving the example of the hospital, so patient as an object which is moving in the hospital process. Okay, similarly, if we are talking about the manufacturing, so the raw material, the product is a flow unit. So we are trying to maximize the flow of that particular object from that particular process, which means we are trying to minimize the interruptions. When we are saying minimize the interruptions, that means we are talking about minimizing the wastages, minimizing the non-value added activities. Okay, once we would be able to minimize those one, however, we would be able to improve the flow of our product. And the next thing in a pull, which means produce only when the next customer want this from us. Do not produce on a push perspective, which means do not produce according to your capacity. Produce only when it is needed. That is the pull, which means whenever the customer, and when I'm talking about the customer, that means we are talking about the next department speed perspective. So that's why when we are saying the lean, if you are going to implement the lean, so you can adopt this lean principle, or even you can adopt this DMAIC methodology, or either you can adopt the methodology which I was talking about earlier, which was PDCA cycle or the A3 reporting. So whatever the methodology you want to do is, but all the methodologies having certain links. with each other. Okay, but talking about the Six Sigma or the Lean Six Sigma perspective, uh, so the DMAIC methodology is the most famous one in order to implement these programs. Okay, so in this particular slide is I'm showing you the ultimate target of the lean is to waste removal. The ultimate target of the Six Sigma is the waste reduction. So ultimately we would be able to improve the process. So that means when we are able to reduce the wastages, which means we would be able to improve our lead time. Okay, we would be able to deliver the product fasterly to the customer. Okay, so that means we are talking about the time reduction perspective, whereas in Six Sigma we are ultimately targeting the quality. Okay, in both the programs we would be able to reduce the cost. Okay, so that means the lean is ultimately focusing on the efficiency improvement, whereas in Six Sigma we ultimately improving reducing the variation. So this is basically I'm showing you the lean principle. This is the DMAIC methodology, and here I am giving the some set of tools which we can adopt. So these are the purely lean related tools. So these are the common tools. Even if I am going to implement purely a lean project, so I can use these tools in order to implement the lean. If I'm going to implement the Six Sigma project, so these are the Six Sigma related project. These are the common tools. So now people are going to talk about the combination of the Lean Six Sigma program. So that means we can have must have the all the tools knowledge. So here I am giving the some few tools example. So not all the tools are mentioning over here. So in order to implement the Lean Six Sigma project, so we must have the Lean tools as well as the Six Sigma tools knowledge, that however we would be able to improve the efficiency of the process, as well as we would be able to reduce the variability in our process, that the ultimate target is going to be reduce the cost. So I hope you got the idea what is a Six Sigma is. So if you have any questions, so most welcome. So if you have any question, so basically the recording of this lecture is going to be I'm going to be posted on my YouTube channel. So that is basically with the name of my name. You can check that. Let me show you. So you can check from my YouTube channel. So over here I am going to post this lecture. So you can even check this lecture after that. So if you have any question, you can also email to me or you can ask from Dr. Asif. So if you have any questions, so most welcome. I hope you got the clear understanding about what is Six Sigma is. Yes, Dr. Asif. Can you hear me? Hello, Dr. Asif.
We can hear you.
Okay.
Yes, we can hear you.
Yeah,
But at Professor Asif, I'm not sure.
yeah.
But thank you very much for the presentation.
Most welcome. Most
For the
welcome.
lecture, I mean.
Most welcome. Hello, Dr. Asif.
I have a question.
Yeah, please.
So generally speaking, in a company, is there one person that like runs these, like checks the six, like does all these processes, like checks the measurement of the, the the processes that they have, whether it be in the post office or in manufacturing. Is there one person that handles it, or is it like
No,
per
no.
department there's someone that's doing it?
Basically, it's a teamwork. It's all the department person can be involved in that one. As I was showing you the Six Sigma team structure. So in your organization, if you are going to run a Six Sigma project, so you must have the black belt person. Okay, you must have the green belt persons. So they are acting as a team members. So if you do not have, you may hire some consultants as well. So normally there is only a guy who can run this entire project, which is basically monitoring that project. So that guy must have the black belt certification. So you can check from the Google. So there are multiple body who are basically providing these trainings as well as the certification, like American Society of Quality. There is a body, example Global USA, that is also a body who is delivering. ILSSA UK is a body who are providing these certification. So basically, in those certification, you will get these set of tools knowledge, and they after that they will take the exam and they will certify a person as a black belt or a green belt guy. So once you are getting that black belt, so that means you can be working as a project manager in that particular organization to improve the process. Okay, so under you there would must have a certain set of green belt who are acting, or you can say supporting to you and implementing those tools and techniques. But it is not compulsory that it is only the responsibility of one person. Obviously, it is the main responsibility of the person where you are implementing that project. Okay, so the, like for example, if I give you the example from the textile sector, if I'm implementing this Six Sigma project in a sewing department, so that means you do not may have the knowledge of stitching, okay, but you have the knowledge of the Six Sigma. So for the swing related knowledge, so you need that guy who's working or is the responsibility for that process. But technically, you would be helping them how you can improve this particular process. So this is not only a one person's responsibility; it's a responsibility of the whole team of which you have selected for that particular project. So normally, according to my experience in a Six Sigma project, it should be at least 8 to 10% involved in that particular project to improve a certain process. I hope I give you the answer.
Yes, you did. You answered it very thoroughly. Thank you.
Welcome.